Hey, for this video, we're going over long division. So the standard for this video is MA.4.NSO.2.4. Divide a whole number up to 4 digits by a 1-digit whole number with procedural reliability steps. We also want to be able to represent remainders as fractional parts of the divisor, and we're going to talk about that in this video. Now, we want to label the parts of our equation. We want to make sure we know what we're talking about when we say things like divisor. So the divisor is the number doing the dividing. The remainder, in this case, we don't have a remainder, but the remainder would be the number that is left over. So if we were dividing by anything that other than a multiple of 4, we would have a remainder or just something left over. This number here is our dividend. Then the number that goes on top of the house is our quotient. Now, I have some steps listed here, and traditionally, we would only really do steps 2 through 6, but if you have some challenges with multiplication, maybe you don't have all your multiplication tables memorized, one of the first steps that's going to help you is to list your multiples, which really just means you're going to count by whatever your divisor is. Okay, so in this case, our divisor is 3, and we're going to list multiples of 3. A question that I get a lot is, when should you stop counting? And I'm going to give you that hint right now. 3 is a 1-digit number. When I look at the first digit of my dividend, 174, I see there's a 1 there. Now, there are, 1 is not a multiple of 3. It's too low a number. Our lowest multiple is going to be the number 3, right? And so I'm going to look at 2 digits to get an idea of where to stop. I'm going to look and list my multiples until I get to a multiple that is as close to 17 as possible without going too far over. So our first multiple is 3. If I add 3 to that, or count by 3, my next multiple is 6. Add 3 again, my next multiple is 9, 12, 15, and I'm getting close here. I have a 17. I'm going to stop at 18 because now I have a multiple that is larger than my dividend. So the largest multiple that I can get out of 17 is 15. My next step is to divide. I'm going to divide 15 by 3. 15 divided by 3. If I use my multiples to help me out, that's 1, 2, 3, 4, 5. So 15 divided by 3 is 5. Now, this next step is going to sound redundant. And the reason it sounds redundant is because we used our step 1 to help us out. But normally, if you know your multiples, you don't use step 1. So our next step is to multiply. We're going to multiply the number that we wrote in our quotient by our divisor. So 5 times 3 is 15. Now we're going to subtract. 17 minus 15 is 2. We're going to bring down the 4, and now we have 24 divided by 3. Now, if you know your multiples, you don't need to continue listing multiples, but in case we don't, we're going to go ahead and do that now. So after 18, we have 21, and now we have 24. The largest multiple we can take away from 24 is 24. So 24 divided by 3 is 8 times 3, that's our next step after we divide, is 24. 24 minus 24 is 0. We have no remainders, so even if our question were to ask us to write the answer as a fractional part, our answer would still just be 58. Okay, we're going to move on, try this one more time, and also try to see what it'll look like with some remainders. So step 1, list my multiples and stop when I get to a multiple that is as close as possible to my 2-digit dividend, since 2 is smaller than 5. 5, 10, 15, 20, 25. So the largest multiple I can get out of 23 is 20. 20 divided by 5 is 4. 4 times 5 is 20. 23 minus 20 is 3. And then we want to bring down the 5. 35 divided by 5, I can list some more multiples. 5, 30, and 35. So 4, 5, 6, 7. 35 divided by 5 is 7. 7 times 5 is 35. So I have 35 minus 35. I have no remainder, so the answer to this question is 47. Now, remember, a remainder is the amount left over that cannot be divided evenly by the divisor. So we're going to do this again, only this time we are going to have an example with a remainder, and we're going to take a look at how we're supposed to write it as a fraction. So first step, list our multiples. If we know our multiples, we don't need to list them, but this is a good guiding step. We have 7, 14, 21, and then 28. So the largest multiple I could get out of 25 is 21. 21 divided by 7 is 3. 3 times 7 is 21. 25 minus 21 is 4. Now, there's no other digits after my 5 for me to bring down, so I'm done dividing. My answer right now is 3, remainder 4. Now, when I'm writing my answer as a fraction, I want to remember that the bottom number in my fraction, my denominator, is the number that divides something up. So in this case, our divisor does the dividing. Our denominator is the same thing as our divisor. They both do the same job. Now, the numerator is the number of parts in the whole that are counted, or in this case, it's going to be the number of parts that are left over. So in this case, our numerator is our remainder, 4. And then our whole number, or our quotient that we have up here, is going to be the number 3. So we have 3 and 4/7. Okay, we're going to practice the skill One more time. We have 379 divided by 6. We're going to list our multiples. 6, 12, 18, 24, 30, 36, and 42. Now, the greatest multiple I could get out of 37 is 36. 36 divided by 6 is 6. 6 times 6 is 36. 37 minus 36 is 1. Now I've got 19. The greatest multiple I could get out of 19 is 18. That's the third multiple of 6. So 18 divided by 6 is 3. 3 times 6 is 18. 19 minus 18 is 1. So we have 63, remainder 1. And again, we want to try to write this as a fraction. So 63 becomes our whole number, and our divisor is our denominator. So 6 goes on the bottom, and our remainder becomes our numerator. So 63 and 1/6, or 63 remainder 1 is our answer. Now, those same steps work even with 4-digit numbers. No matter how many digits we have in a number, we have the same number of steps. So in this case, 5 is larger than 4. When we're listing our multiples, we can stop at 8 because 4 goes into 5. So 5 divided by 4 is going to be 1. 1 times 4 is 4. 5 minus 4 is 1. Now I'm going to bring down my 2. 12 divided by 4. When we continue our list, we see 12 is one of the multiples of 4. So 12 divided by 4 is 3. So we have 3 times 4, which is 12. 12 minus 12 is 0. We bring down the 3. And we can't divide 3 by 4 because when we look at our list, we don't have a multiple of 3. So 3 divided by 4 is 0. 0 times 4 is 0. We still have this 3. We're going to bring down our 7. And now we've got to add more multiples to our list. So 16, 20, 24, 28, 32. Ooh, just noticed I didn't write the 7. 36 and 40. So the greatest multiple of 4 we can get out of 37 is 36. This is a pretty long list, so I'm actually going to count it with you. 1, 2, 3, 4, 5, 6. So notice whatever number they are is really just the number that we would have multiplied 4 by to get that multiple. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, 4 times 8 is 32, and 4 times 9 is 36. So the highest multiple is 36. That means 36 divided by 4 is 9, and 37 divided by 4 is going to be 9. 9 times 4 is going to be 36. 37 minus 36 is 1. So our remainder here is 1. Notice we didn't have any other numbers to bring down after our 7. That's how we knew we were done multiplying and could write our remainder. And if we want to write it as a fraction, we got to remember the quotient makes the whole number. so 1,309, and the remainder divisor becomes our denominator. I really hope this helps. Thanks for watching.
Hey, thanks for watching. I want to encourage you to keep practicing. If you need some resources for extra practice, you can check out my Teachers Pay Teachers store. The store is linked down below. Bye!